Vectors 1 tutorial 3 on vector product. Alright, so we are looking at PQ question 1. Relative to an origin, the position vectors of ABC are respectively 2, 1, 1, 2, 3, 4, negative 1, negative 7. So this negative 1, negative 4, negative 7, 2, 3, 4. Alright, so as a habit of mine, what I do is I always try to write it in a column vector form. I find a vector which is perpendicular to AB and AC. Now, this is a tutorial on vector product. We know that one of the things that gives us perpendicular vectors if we were to do vector product. So recall that if we have A vector product with B, this will gives a vector that is a perpendicular. Right, this is from the definition, and in your notes, this will give us a perpendicular vector that is perpendicular to both, alright, A and B, right? Because this is from the, like if you take a right hand and you do the rotation, you can actually see the what is the visual representation of vector product of A and B. Alright, so basically, vector product of A and B will give you a vector that's perpendicular to A and B. Alright. So next, we need to find a vector perpendicular to AB and BC. So easily, what we can do is just find AB, find AC. The strategy is we take AB, we find BC, and then we take the vector product of AB and BC. Alright, so we know that this is OA, OB, OC. Alright, so next what we're going to do is very quickly we'll just find AB and BC. Alright, okay, I'm going to leave you to do this by yourself, and I think you can find easily that AB, right, this is just equals to OB minus OA. Alright, and it will be equals to 0, 2, 3. BC is equals to OC minus OB, and that will give you negative 3, negative 7, and negative 11. I'm writing a bit slower because of the pen. Okay, so hope you can understand. Okay, so it's negative 3, negative 7, and negative 11. Alright, so quickly, we want to find a vector that's perpendicular to AB and BC. All we need to do is we just take the vector product of AB and BC. Alright, so we just take the vector product AB and BC. Right, this means that we are taking 0, 2, 3 cross product with negative 3, negative 7, and negative 11. Right, and I hope you can do this by yourself. Okay, I think by now you should be able to do the vector product comfortably by yourself, and your answer will be negative 1, negative 9, and positive 6. Alright, and this is perpendicular to both AB and BC. Okay, next we are looking at part B. Okay, so part B, what we need to do is we need to resolve. We need to resolve the component. Okay, PQ into two vector components which are parallel and perpendicular to AB. So resolve means we need to project. Okay, we need to resolve just means project. Okay, PQ into two components which are parallel and perpendicular to AB. So if you think about it, right? Okay, PQ is as though we're looking at PQ in mid-air. This is P, and this is Q. Alright, AB is on the floor. Alright, we are projecting PQ, okay, into two vector components, one of which has to be perpendicular. Alright, so let's say if we're talking about this blue component, right? This blue component is the one that's perpendicular to AB. Can you see that this is perpendicular to AB? Alright, say we form a right angle triangle, okay? And if you look at the other line, we want this to be parallel to AB. So this is the component that we want it to be parallel to AB. Right, so AB is lying in the air. We have the blue component which is perpendicular to AB. Right, so perpendicular to AB, and the other components are parallel to AB. So how do we find the blue and green vector? Right, the blue and green vector. Again, all you need to do recall this vector components. Okay, the vector component of A onto B is A dot B hat. Alright, so can you see that the projection of component A onto B, this vector itself, alright, is the, sorry, let me, okay, this itself, this vector over here, this green vector is actually parallel to B. Can you see it? This vector actually is also parallel to B, and A minus A dot B hat, right? This is actually the blue vector which is also perpendicular to B. Right, so what we're doing is we're actually going to use this formula for our question. Right, the green vector over here parallel to AB, right, is over here, right, and blue vector is over also the perpendicular to AB. So what we're going to do is we're going to use this formula A dot B hat, right, to find the parallel component of PQ onto AB. Alright, so for PQ, what's the component of PQ? Okay, so we have PQ, alright, and you know that PQ over here has to first be found. Okay, so PQ is not given yet, so PQ is equals to OQ minus OP. Okay, so this from the question, which is OQ is just 4, 7, 11, OP would be 3, 5, 9, and PQ would be 1, 2, 2. Alright. Okay, next, you know that one thing that we probably need is, okay, we have the AB, right? So just now we have the AB, and both formulas require that, you know, for our AB that's lying down, we always need a B hat. Alright, so what we're going to do is we are going to find the unit vector along AB. Okay, so what we're going to do, because we know that we have PQ, we have AB. Alright, what we do is we need to find the unit vector that lies on AB. Alright, AB is the vector 0, 2, 3. Alright, so what I'm going to do is I'm going to use the maybe take a unit vector, like let's say call it N. Alright, let's call it N hat. Alright, and let N hat be the unit vector of AB. Okay, because I'm going to use this quite heavily later on. Alright, and the unit vector of AB you can actually find easily. This should be 2 square, 3 square, so we have 2 square plus 3 square is 13, square root of 13, so N should be equals to 1 over square root of 13. Alright, 0, 2, 3. Okay, and next we want to find the vector component of PQ that's parallel to AB. Alright, if we have, based on the formula, this is A and this is B. Alright, we want to, okay, assuming that these two are the same, right? So we want to find the parallel component of A onto B. This formula here is none other than A, dot B hat, okay, multiplied to B hat. Alright, so this is from the question we have, right? A dot B hat multiplied to B hat, right? Okay, so this is the parallel. So if we used our question, the A over here refers to PQ. What is PQ? PQ is 1, 2, 2. Alright, so that means come over here, we erase this. Our A over here refers to PQ, which is 1, 2, 2. This is P, this is Q. Okay, next, what is AB? AB, B we know. Okay, so B actually is our AB. Right, this is our AB. Alright, and AB is equals to 0, 2, 3. Alright, what we do is we need a unit vector that lies along AB, right? So the N over here is actually equals to 1 over square root of 13, 0, 2, 3. This N over here refers to the B hat that we have here. Alright, so very quickly, what's the answer? All you need to do is just sincerely and honestly use this formula. A dot product and B hat. So it's 1, 2, 2 dot product with 0, 2, 3, 1 square root 13. So it's 1 square root 13. Right, we put the 1 over square root 13 outside since it's a scalar, it doesn't matter. Right? 1, 2, 2. Dot product with b hat over here, 0, 2, 3. My b hat is here, so this my b hat is here. Alright, just that I put the 1 over square root 13 outside because it doesn't matter, right? For scalar, for dot product, we can just put it outside. Okay. Alright. So next, b hat. This portion refers to this portion. Right. Next. So b hat itself. Okay. So it's maybe just let me rewrite the whole thing. Right. Okay. This is we have PQ. Alright. Dot product actually with n. N is the unit vector that lies along AB. Alright. Alright. And PQ would be 1, 2, 2. N itself is 1 square root 13. 0, 2, 3. Right. This is the entire scalar together with n. N which lies outside is 1 over square root 13. Now it can be a handful, so slowly. Okay. So again, this portion represents the n hat. This portion represents the n hat. This portion represents PQ. Right, we are finding the component of PQ parallel to AB. Right, and solving this, okay, the scalar we can move it outside, so we can put it as 1 square root 13. Okay, 1, 0, 0. 2 and 2, 4. 2 and 3 becomes 6. Right. This again multiplies by 1 over square root 13. Again another scalar, okay, of the vector 0, 2, 3. Square root 13 and square root 13, alright, these two will cancel off to give you 13, and this portion will give you 10. So eventually you just have 10 over 13, 0, 2, 3. That is the answer for the parallel component to AB. Right? We are solving this portion where we are looking for a PQ to two components. This is the one that's parallel to AB. Okay, so again, the answer for this is 10 over 13, 0, 2, 3. Alright, next, we want to find a vector component that's perpendicular to AB. So very easy. What we can do quickly, we can just do vector product. Alright, or we can use a hardworking way, which is take this. We use this method, a minus a dot b hat b hat. Why am I using this? Because I've already found this is a dot b hat. Right, we have already found this answer just now. So basically, your vector component of A perpendicular to B, right, is just A minus the parallel component, right? Which means that our part B answer, right, is just P, okay, just A minus the prior answer. Okay, so going back to what I said, this is PQ. Alright, PQ over here is 1, 2, 2, and the parallel component, as we have found as earlier, is 10 over 13, 0, 2, 3. Alright, the last one, or green portion here, the vector that is perpendicular to AB, which lies on the bottom. Alright, this is none other, so based on the just a vector, okay, and triangular law addition. Right, what is this vector? This vector, okay, sorry, wrong direction. I should be, okay, it's just, okay, this vector minus this. Alright, so we also, okay, sorry, this vector minus this. So we just take PQ minus, alright, because from here to here, minus the blue portion, which is 10 over 13, 0, 2, 3. Okay, and that will be 1, 2, 2, subtracting 10 over 13, 0, 2, 3. Okay, and the answer will be 1. 6 over 13 and negative 4 over 13. Right, that's your answer for part B.